Hello everyone, we are going to start the P delta analysis. I have divided the P delta analysis into three parts. The first part will be theory part, where we will see that what actually the P delta is, what is the importance of the P delta, and what all the theory regarding the P delta is there. In the second part, we will see that which type of the structure you require the P delta analysis, and we will see that in our structure which we are doing that we require the P delta or not. And in the third part, we will see that how we can apply the P delta in our project. Now let us start the P delta with the theory part. So for explaining the theory part, I am opening the PPT here. So I will send this PPT in the download section so you can download it and study it. Now start with the P delta definition here. But before starting the P delta definition, let me tell you that P delta is also known as a second order effect. So you may call the P delta as a second order effect also. Now come to the definition here. P delta is a non-linear second order effect. So please remember that P delta is not a linear, it is a non-linear effect here. And this comes under the geometrical non-linearity. So when it comes to the non-linear, there are different type of non-linear and it comes under the geometrical non-linear categories. Now read the next line here, that effect that occurs in every structure. So P delta effect will be occur for every structure where the elements are subjected to axial load. So where there will be element like a columns and all, when it is subjected to axial load, then the P delta will occur here. It is a genuine effect, means it is a real effect, and that is associated with the magnitude of the applied load, and this effect is associated with the what applied load is applied here, and the displacement, that is a delta, and what displacement is caused here. And if you look at that next here, the magnitude of the P delta effect related to the magnitude of the axial load, what actually load is there, a stiffness and slenderness of the structure as a whole, what actually the stiffness as a whole structure is providing you, and also the slenderness of the individual element, what actually slenderness effect is having for the individual element. So what the definition is written here, I will explain you this thing in very detail now. Now look at this picture. So in this picture there is one column here, and in this column I have given a fixed support here, and when you apply the fixed support, now the height of the column is your h here. So this is the h of your height, that is the height of this column. And now in this column we have applied a lateral forces, in the terms we can call it as a B here. And also as you know that the P is already here, that is axial forces, then this P is I have denoted with the P here. So due to these forces, the column actually has got displaced, and this displacement I can call it that we are getting a displacement of delta here, and we call it as a delta. And along with delta, the P is also here. So if you find a moment here, if you want to interested in finding the moment, if you are interested in looking the moment here, that is AM total, then this will be a primary moment. So primary moment is caused by V multiplied by H. So what the lateral forces you are applying and what the H is there, and due to that what the moment you are getting, that is a primary moment. So I can call it here as a primary moment PM, that is a primary moment. And also due to this lateral deflection, one another moment is causing, and we will call it that P multiplied by delta here. So what the axial force you are having, this is the P, and what delta it has been moved, due to this also one moment has been created, and we will call it that this is secondary moment. So if you want to find a total moment here, then this will be a primary moment plus secondary moment. The primary moment will be caused by what the V is there and what the H is there. On the basis of that, what the moment you will get it, that we will call it as a primary moment. The secondary moment will be caused what due to these forces, what the displacement is caused, and what already P is there, and due to this what actually will get it, that will be a secondary moment. So there is a two type of moment will be occurred when there will be lateral forces and P is applied to this column. Now the primary moment will be V multiplied by H, and the secondary moment will be P multiplied by delta, and this is only we call it as a P delta, or we can call it a second order effect. Now look at the diagram here. So this is the diagram of the primary moment, which you can see that the maximum moment will be at the base here, and if you look at here as a diagram of the P delta, the maximum moment will be somewhere here. Now look at the second diagram here, which is this, and if you look at here that in this we have only the axial loaded, and due to this axial loaded we are getting some bending here, and we can call it that this is we have a small delta here, and due to this we are getting a moment that is a P multiplied by delta, and this delta we will call it as a small delta. So due to this axial load, we can say that we are getting one more moment, that is a P multiplied by delta, and this is a small delta. So this small delta we do not consider in our design. We actually ignore this p multiplied by small delta. We consider only this delta, which is a big delta, which is caused by the lateral forces here. Now if you look at here, that magnitude of the p delta effect is related to the magnitude of the axial loaded here. So what the axial load we are getting, it depend upon that. So let's suppose that if axial load is more, then the p delta effect also will be more, because you can look at here that the p multiplied by delta it is second order moment. So how much the p will be there, on the basis of that this p delta will also depend. Second is that a stiffness, or we can slender of the whole structure here. So if your building a stiffness is very low, in that case your deflection will be more there, because I told you in the previous class, in the stiffness classes, I told you that if your structure is more stiff, then displacement will be very less. If your structure is less stiff, in that case displacement will be more there. So in case where there will be a more stiffness, then deflection will come. In that case the second order effect will also get decreased there, that is p delta will get decreased. So this also depend upon what a stiffness as a whole structure is providing you. Also if you look at that, what the slenderness of the individual element is that. Suppose that if you are designing a long column, in that case there is more slenderness effect there will be there. In that case your p delta effect will be more in that case. So if you look at the long column design, in that we have to consider the p delta effect there. Now I think you understand that what is the importance of the p delta and what actually these all things are related to that. Now I will explain you this whole thing once again in the ETABS model. Now let us open the ETABS software to explain this. I have been in ETABS software here, and I have taken one model here as a prototype model to explain you what actually the effect will be caused here to the p delta. Now in this column which I have taken here, I have given a fixed support here. So if you look at here, the restraint ux, uy, uz and rx and ry and rz also I have applied it. So we have given a fixed support here. If you look at the load here, so if you go into display option and load assignment, and if you look at the joint load, let us start with the p load which we have given here. So the p we have applied here is your 50 kilonewton. So the p load which we have taken is of 50 kilonewton. Now if you look at the lateral load which we have applied it, we have applied a lateral load of 10 kilonewton. So the condition what is there in my picture, if you look at that, if you look at the same condition I have applied here, I have taken a column. So this is the same column I have taken, and in this I have given this as a fixed support at the joint, and also I have given a lateral forces here. So the V is here is 10 kilonewton and the P is here is 50 kilonewton. So the same condition how it was there, I have given here in our ETABS model to explain you that what the p delta effect will be applied when the V is given and the what actually delta will be there. Now come back to our ETABS. And also in this ETABS model, I will remove the self weight here. So for removing the self weight, you go to load pattern here, and in that what the self multiply right now is 1, you give it this as a 0 here. So when you will give it this 0, then self weight will be get cancelled here. So no self weight is applied here, so self weight is completely 0 here. Now only the load is there is of 50 kilonewton, which is applied here in the form of gravity as 50 kilonewton, and against the gravity we have applied as a lateral load of 10 kilonewton. Now run the analysis. Now the analysis has been completed. Now let us look at the moment here. If you look at the moment in the dead, then this will become 0. As you know that due to the dead load, there will no any moment created here. Now if you look at the same thing in the lateral load here, then there will be moment here, and the moment will be of kilonewton of 30 kilonewton meter here. So if you look at the base here, the maximum moment will be at the base. So 30 kilonewton meter, the base you will get that much of moment. Now you give it done here and you give it close here. Now same thing what we have studied in this particular picture, the same thing we are getting here, that the moment we are getting maximum here at the base only, and this moment is caused by the due to the lateral load. Now let us look at that when we applied the p delta, then what the moment will come. Now let us look at that part. So again unlock this model, and after that you define one load cases which will contain a p delta here. So in the lateral load cases, you add a copy of case here, and you can make it like lateral load with p delta, lateral load with p delta. After that everything will remain same. Only thing you have to do is that use preset p delta setting here, and in this right now is none. You modify this and you give it that irritative based on the loads. So the dead will be 1.2 and the live will be 1.2. So this actually I will explain you that why this dead is coming 1.2 and why this live is coming 1.2 in the upcoming lectures. Now same, everything will remain same, only you have to give it the p delta setting here, and you give it OK, and you give it OK, and you again run the analysis. So in the before, what we have done, we have not given the p delta analysis here, we have not considered the p delta effect, you can say that. But right now what we have done, we have done the p delta analysis and we have considered the p delta effect in that. So actually the p delta is not analysis, we can say the p delta is effect here. So after applying the p delta, you will get a p delta effect. Now let us look at the moment with p delta. So you will go to display frame forces here, you will select the load cases which will be lateral load with p delta, moment will be m33, you apply it and look at. So if you look at here, that before that we were getting a moment of 30 kilonewton meter here, but right now we are getting a moment of 30.1340 kilonewton meter here. So there is a little change here which is caused by the p delta effect. So the moment which is getting here is both, that is a primary moment plus also we are getting a secondary moment also. So the primary moment is about 30 kilonewton and plus we are getting more, that is a 1.40 of kilonewton moment, that is a secondary moment. So if I will give it like m total, which will be of primary moment which we are getting of 30 kilonewton meter plus as more moment we are getting of 1.340 here. So when you will add it here, then you will get it 30.1340, which is caused by p delta. The extra moment of 0.1340 we are getting now, this is only, as we can call it as a secondary moment here. So this is the secondary moment and this moment is only caused by the p delta effect. Now let us find out exactly the calculation here. Now I will explain you that how exactly you got 0.340 as a secondary moment. Now if you look at that your PPT here, I already told you that the secondary moment will be p multiplied by delta. So this was the secondary moment we got it, that is secondary moment, and that secondary moment is depend upon what the p is and what the delta it is. So if you multiply p multiply by delta, you will get the secondary moment. Now let us look at that in our ETAS model which we have prepared, that whether we multiply p multiply by delta we are getting the secondary moment exactly what we are finding out is there or not. So let us do and find out that. So I will open again my ETAPS model here and I will find out here that exactly what delta we are getting, and the p already we know that p we have applied a 50 kilonewton. So if you remember that we have applied a p of 50 kilonewton and also we have neglected the cell weight, so total p will be only 50 kilonewton. So if I will see the deformation here, I will open a new window for looking that deformation. Now you go to show deform shape here, you select the lateral load with p delta here and you apply it. Now you look at the deformation what actually we are getting. We are getting a ux of, we will look at the deformation in the x direction and this is 2.234 here. So if you just see that 2.23 I think, yeah, 2.234, you divide it with 1000 to convert into meter. So you will get it a displacement, that is delta 0.002234. Now we got the delta here. So initially our column was somewhere here, and when we applied a lateral load it got deflected and it went somewhere here and we found a delta. You already know that a p is there, so p is exactly we have a 50 kilonewton. So this is the p we have. But if you remember here that when we were defining the p delta, in the definition of the p delta I was doing here, I have given some factor here. So if I open the p delta option here, you can look at here that we have given a dead, that is 0.12. So in the calculation the p will be 50 kilonewton multiplied by 0.2, so this will become a 60 kilonewton. So when you multiply this 50 by 1.2 you will get 60 kilonewton. Now you calculate p delta, that is p multiplied by delta. So this will be 0.00234 multiplied by 60. Now you calculate it. So it will be 0.00234 multiply by 60. Now you got the value, that is 0.13404. so this is only the, we are getting the kilometer meter, and this is only the secondary moment we are getting, and this is caused by the P delta effect. So if I will open my moment diagram, and if I would like to show you, you can just see here that you already know that, so M total will be primary moment plus secondary moment. So secondary moment, already you know that this will be a height multiplied by a lateral load. So height was 3 meter and lateral load was applied as a 10 kilonewton. So this become as a 30 kilonewton meter plus secondary moment, which is this moment. So if you add this of the moment, and this is caused by P multiplied by delta, so this will 0.3404. so when you will add these two of this, it will become 30.340. so exactly what you're getting here, you're finding same thing here. Now I think you have understand how the whole calculation of the P delta, how actually is there. Now this thing we have applied into single, we can say a column here, but how the whole structure will behave it. So anyhow you will prepare the whole structure, and then this P delta effect will be applied in that. So this whole calculation is the same there also, only as there is a column, there will be a building as a whole structure, but the calculation will remain same. Now I think we are very clear about how the calculation work for the calculating the P delta. Now we have already seen that how the calculation of the P delta actually is done. Now come back to the PPT which we were discussing here. So this, I think already you know that how the calculation and all are done. So I think there is no any problem in this particular topic of the P delta right now. The definition part, I think it is very clear to you. Now come to the second page of this PPT. Here you will find a difference between a small delta and a big delta. So little bit already explained in the first page of this PPT that when you apply the lateral forces here, suppose this is the lateral forces, then this lateral force caused the two delta here. One is your the big delta, which is this delta I am talking about, and second is your the small delta. So this is the small delta which is presented here. So every time when you apply lateral forces, there will be two delta applied here, one which is big delta and the second will be a small delta. Now I think you understand that. Now if you look at the second point, the P delta effect applies to the member only and involves a modified bending moment acting along the length of the member. So the P delta effect, actually I told you the P delta effect, and that effect applies to the member, and due to that involves a bending moment acting at the length of the member. So the effect is, you can see here in the form of the bending moment, and this will be along the length of the member, where you found that in our case also your bending moment was affecting due to the P delta. Now if you look at the second thing here, that the column experienced not only an axial load, that is a first order. So if you look at the columns which I already shown you, that it was not experiencing only the axial load, it was experiencing more thing, that was a moment which was equal to the vertical load, which was a P multiplied by delta. So this was also the column was experiencing. Now interestingly you will find one word there, that a first order. So what actually the first order? If I already told you the P delta is a second order. So what the terms mean second order, what the terms mean the first order and all. Now try to understand this thing here. When you do not apply any forces, let's suppose that when I am in ETAPS right now, suppose let's open my ETAPS here, and I will show you this thing, what actually the first order means to say. Now let's suppose that when you go to deform shape here, so your structure got deformed here. Now let us take an example here, that when we look at the deformed shape here, due to the lateral forces which is applied as a 10 kilonewton, and your axial force is 50 kilonewton here. Now when I will say that this is the first order. So if you look at here, when we apply the lateral forces here, now if I will count a moment here, this moment is very simple, that you will get a moment of 30 kilonewton, that is 3 multiplied by 10, because the simple thing is that we have applied a 10 kilonewton of load and the height is 3 meter, so you will get a 30 kilonewton meter of the moment here. But when the force got applied, it got deformed also. So if I will count a deformation here, that maybe I think it was 2.2234 mm. This was deformation we got due to this. So after applying the lateral load only you got the deformation, and if it is got deformation after lateral load and when the P delta is counted, then this will be a 2.2234 multiplied by 50. So this is after effect, no? When the lateral load is applied, that was the first order, but no, when due to that lateral force it got affected, then we will call it that this is the second order, because this is happened after the force got applied. So that's why reason why you call it is second order. Now the first order is due to the lateral load and what the axial force it is there, that the same thing, and due to that point it got deformed. Due to the lateral load it got only deformed, no? Then due to that what effect it will come, we will call it that it is second order effect, because it is caused by the first order, which was a lateral load here. Now come back to our PPT. Now let us look at the third point here, that the P delta effect is generally less important and the result from the bent shape of the member that is carrying is an axial forces. So this is talking about the small P delta here. So the small P delta which is caused here you can just see this is a small P delta. Effect is generally less important. This effect is not that much. I already told you before also. And this is result is due to the bent shape of the member which is carrying an axial forces. So due to the axial forces is happening, due to that you will get a bent shape, and due to that this delta will come. So you can ignore this P as small delta. Now come to the another slide of this PPT. This slide tells you what P delta analysis in depth. So they are given you specify the P delta analysis is available. The P delta analysis is basically consider a geometrical nonlinearity effect directly. So these all things what is already I told you, some are left here to be told, like the buckling analysis is not a P delta. So if I will explain you the buckling analysis, there I will explain you the difference between what actually the buckling analysis and what actually the P delta is. No magnification of the moment is needed if P delta analysis has been carried out. So when I will explain you the column design, in that time I will explain you the magnification of the moment, where I will explain you that when you're doing the P delta analysis, in that case no need to actually give it or we can say no need to give it a magnification factor here for doing the column design when the P delta is carried out. So I will explain you these things when we will encounter in the design and all. Now come to the last page of this PPT, second order analysis here. So this thing also I have explained you. So if you have any problem there, you can ask me in the comment box. Now we have came to the end of this P delta theory part. So we have learned a lot of things regarding the P delta here. We have learned that how the calculation of the P delta is done. Also we have learned that what actually the P delta big, what is the P delta small. So these are things we have learned in the P delta theory part. Now in the next part we will see that whether in our building which we are doing that we require a P delta or not. So any structure you are doing, whether in that structure the P delta is required or not, we will look at in the next part. We will check that whether our structure also required a P delta or not. So that we will look at in the next part of this lecture. See you in the next part. Thank you.